Guys, in this video I'm going to run you through some useful techniques that would be a really good idea to sharpen up before the non-calculator paper. So I'm not talking topics here, mostly I'm going to go through multiplication, division, fractions, decimals and percentages. Pretty much every question on the non-calculator paper is going to be some application of these skills, with addition and subtraction too. So, if you're looking for topics to revise, I've already done this video. So, in this video I go over which topics I highly recommend revising for the non-calc paper. I've also gone through all of last year's non-calculator papers that I'm allowed to put up. They are all arranged in separate playlists, and I will put a link to each of them in the description of this video. So that's just down below the video, down there. So all of them are there to be used. I would highly recommend going through them. Past papers are the best way to revise. So what I'm going to do now then, I'm going to run through questions and give you or show you the method that I would recommend either learning or practicing. So let's start off with some multiplication. Let's say we wanted to work out 29 times 35. Now most of the time when I see people using the column method, it doesn't go that well. So I advise against using the column method if you're not that confident with it. Instead, I would recommend using the lattice method. So, one of the biggest pros of using the lattice method is that you never need to do a multiplication bigger than 9 times 9, which is pretty cool. So this strips away confusion with how many zeros to put after a number, that sort of thing. So how do we do it? Well, we got a 2-digit times a 2-digit number, so we need a 2 by 2 box. Along the top, I'm going to put 29, but I just think of it as 2 and then 9, like that, and then 35 down the right hand side, like that. Now, each box is a multiplication between the number at the top and the number at the side. So, starting top left, 2 times 3 is 6, which is a single digit number. So, we put a 0 in the top left, 6 bottom right, like that. Top right one, 9 times 3 is 27. Bottom right, 9 times 5, 45. Finally, bottom left, 2 times 5 is 10. So, we've done all the multiplications. Now we add up along the diagonal lines, starting from the bottom right. So, that's nice. This 5 just falls out. Next line, we've got 7, add 4, add 0. So 7 add 4 is 11. So we put the unit down there, carry the 1 up to the next diagonal. So now we've got 1 plus 2 is 3, plus 6 is 9, plus 1 is 10. So again, the unit goes here, carry 1 up. 1 plus 0 is then 1. So we've got 1015 as our answer. Now what's really useful with the lattice method, say that instead we were asked to do 2.9 times 3.5. The good news is we would do exactly the same as we've done. We now just need to work out where the decimal point would go. So we've got a decimal between the 2 and the 9 and between the 3 and the 5. So what we do now, imagine this top decimal is falling straight down. This decimal on the side is rolling across where they meet. So they meet there. They then roll out on that diagonal, and the decimal is that. So 2.9 times 3.5 would be 10.15, just like that. So, if you've never seen the lattice method, I would highly recommend it. It's very powerful. We never need to do multiplications bigger than 9 times 9. So if you know your times tables, up to 9 times 9, ideal. And we can multiply decimals very simply using this method. Next then we have the opposite of multiplication, which is division. Now I banged on about this in the other video on the topic revision, but it really is an important skill. So for division, I would highly recommend the bus stop. If you can't do the bus stop at this point, I have at least 3 or 4 videos on it. Check it out. It's not difficult. It's just, it doesn't seem to get taught in secondary. It's a problem that rolls on through from primary. The bus stop is so simple. So, let's say we wanted to work out 1023 divided by 3. Without the bus stop, alright, pain in the ass. With the bus stop, not scary at all. So, the number that we are dividing goes inside of the sign. The number we are dividing by goes on the outside. With division, we work from left to right. And we just ask how many 3's go into 1. They don't. So, we put a 0 up on top. We then carry the 1 over to the first 0. How many 3's are in 10? There are 3, which is 9. So we put a 3 up on top, and to work out our remainder, we do 10, take away 9, which is 1. Carry the 1. How many 3's are in 12? There are 4. So 4 goes up on top. 3 fits exactly into 12, so there's no remainder. Then we're asking how many 3's are in 3. We've got 1. So 1023 divided by 3 is 341. Let's do another one. Let's say we want to do 97 divided by 4. Well, that's 97 in here, 4 on the outside. How many 4's are in 9? There are 2, which is 8. So our remainder is 9 take away 8, which is 1. Carry 1. 4's into 17 go 4 times, which is 16. So now we've got a remainder of 1. Seemingly nowhere to put it, except we do. We make ourselves a little 0.0 on the bottom. We can now carry our 1 over to the 0. How many 4's are in 10? There are 2, which is 8. So now we have a remainder of 2. Just create another 0. Whack a 2 on it. How many 4's are in 20? 5. So 97 divided by 4 is 24.25. Okay, so the good news here is if we can multiply and we can divide, we can do fractions, which I'm going to show you now. Okay, so first of all with fractions, a very common thing we need to do is simplifying them. So writing a fraction in its simplest form. This means that there's no common factor between the top and the bottom. So, for example, 18 over 24. Now, we might be able to spot that these two numbers have a common factor of 6. So, this would actually go down to 3 quarters. Another way that we can think about simplifying fractions is using products of prime factors, which is another good skill to practice for the non-calc paper. So let's have a look at doing it that way. So first of all, 18 as a product of its primes can be written as 2 times 3 times 3. 24 can be written as 2 times 2 times 2 times 3. So if we write both numbers as a product of their primes, we can then cancel out common factors between the top and the bottom. So up on top we've got a 2, on the bottom we've got a 2. So we can cancel one factor of 2. Up on top we've next got a 3. And we've got a 3 on the bottom. So we can also cancel a factor of 3. Now up on top we've got a 3. On the bottom we've got 2 factors of 2. So we can't cancel anything else. We're left with 3 over 2 times 2, which is, again, 3/4. Let's have a look at another one. Let's go for 35 over 42. Now we're going to use the method with the product prime factors here. You might not need to, but it will always work. So 35 as a product of its primes is 5 times 7. 42 is 6 times 7, which is 2 times 3 times 7. So the only thing that will cancel here are the 7s. So we're left with 5 over 2 times 3, which is 6. So we've got 5, 6. So there's a nice little technique you can use to simplify fractions. Okay, next up then we're going to look at finding fractions of amounts. So let's say we wanted to find 3/5 of 55. Now this is literally an application of division and then multiplication. So we would first of all want to find 1/5 of 55. So to find 1/5 of 55, we do 55 divided by 5. Our bus stop could help here. Let's do it. 55 divided by 5. 5s into 5 goes once. 5s into 5 goes once. So we've got 1/5 of 55 is equal to 11. So to find 3/5 of 55, we then do 3 times 11, which is 33. So it is literally a division by the bottom of the fraction and then a multiplication of that by the top of the fraction, always. So let's do another one. Let's say we want to find 6/7 of 154. So we first of all find 1/7 of 154, which is 154 divided by 7. Bus stop. 154 divided by 7. 7's into 1, not happening. Carry the 1. 7's into 15 goes twice, which is 14 with 1 remainder. Carry that. 7's into 14 go twice. So 1/7 of 154 is 22. So then we do 6 times 22. The lattice method could help us here. Or we can do it mentally. 6 times 20 is 120. 6 times 2 is 12. 120. Add 12 is 132. One more, where decimals get involved. So let's say we want to find 3/4 of, what should we go for? Let's go for 54. So we first of all want to find 1/4 of 54. So 1/4 of 54 is 54 divided by 4. Bust up. 54 under the sign, 4 on the outside. 4s into 5 go once with 1 remainder. 4s into 14 go 3 times, which is 12. So we've got 2 remainder. Create a 0.0 on the bottom, making sure we put a point on the top. So we're then carrying the 2. 4s into 20 go 5 times. So 1/4 of 54 is 13.5. 3/4 then is 3 times 13.5. Let's have a look at doing that with the lattice method. So for this, we need a 3 by 1 rectangle. 13.5 across the top, 3 down the side. 3 times 1 is 3. 3 times 3 is 9. 3 times 5 is 15. So again, we start from bottom right. So that's just going to give us the 5. Then we've got 1 plus 9, which is 10. So we put the 0 there, carry the 1 up. 1 plus 3 is 4. The last thing we need to do is work out where the decimal goes. So technically 3 has a decimal there. The 13.5 decimal is going to meet that then here. So the decimal actually just goes there between the 40 and the 5. So 3/4 of 54 is 40.5. Okay, so far really we've seen how much we can do just by using multiplication and division. What about now if we go to adding and subtracting fractions? So let's say we want to work out 1/2 add 1/3. So one way that we can do this is by using common denominators. So to do that, we're first of all thinking, what's the first number that 2 and 3 both go into, which is 6. So to turn 2 into 6, on the first fraction, we need to multiply by 3. Now we have to do that to the top 2. So 1/2 is exactly the same as 3 6. With 1/3, we need to multiply 3 by 2. So we do that to the top as well. So 1/3 is 2 6. Now, once we've got the same denominator on the bottom, we simply add the tops together. So we get 3 plus 2, which is 5/6. So 1/2 add 1/3 is 5/6. That's another way of thinking about it. So 1/2 add 1/3. So another way is we multiply the bottom of the second fraction by the top of the first. So we get 3 times 1. Then whatever the sign is between the two fractions, we work that in. So here we've got plus. Then we do the bottom of the first times the top of the second. So 2 times 1. And then that's all over the two bottoms multiplied together. So again, if we sort out the top, 3 times 1 is 3, 2 times 1 is 2, swap on top, again we get 5, and on the bottom, 2 times 3 is 6. Now, I have a fractions playlist where I go through 2 separate videos using these 2 different methods. So whichever one you reckon looks nicest there, if you want more practice, check out my fractions playlist where I take you through loads of examples. Let's have a go at doing a fraction subtraction. Well, here I'm a poet. So let's say we want to do something a little bit more complicated. 7/8 minus, what should we go for? 3/5. Okay, so we'll first of all go for common denominators. So what's the first number that 5 and 8 both go into? So your times tables are going to help quite a bit here. The first number that 5 and 8 both go into is 40. So to turn 8 into 40, we need to multiply it by 5. So we do the same to the top 2. So 5 times 7 is 35. 5 times 8 on the bottom is 40. So 7/8 is exactly the same as 35/40. And for 3/5, we're multiplying 5 by 8, which we do to the top as well. So 3 times 8 is 24. 5 times 8 is 40. That's the whole point. So up on top then we're doing 35 minus 24, which gives us 11 over 40. Let's have a look at doing it with the other method. So 7/8 minus 3/5. We do the bottom of the second fraction times the top of the first. So 5 times 7 minus bottom of the first times top of the second. 8 times 3 all over the two denominators multiplied together. So if we sort that out, we will again get 11/40. Okay, so this is applications of addition, subtraction and multiplication. See, it's all really connected. If you're not happy with the stuff at the start, it's going to carry on through and make you unhappy with all the other stuff. So we've done multiplication, division, simplifying fractions, adding and subtracting fractions, finding fractions of amounts. Let's have a look at multiplying and dividing by a fraction. So first of all, something that I see go wrong quite a lot of the time is multiplying a fraction by a whole number. So let's say that we want to do 2 times, what should we go for? 3/5. Now this is not equal to 6/10. When you multiply a fraction by a whole number, you only multiply the top. So we get 2 times 3/5, which gives us 6/5, which is an improper fraction and something we will come to in a bit. So that's how we multiply a fraction by a whole number. It does not affect the bottom of the fraction. Okay, so what about multiplying a fraction by a fraction? So something like 3/4 times 7 over 11. So multiplying a fraction by a fraction is the nice one. It's the one that works how you think it should. So we multiply the tops. So here we're going to get 3 times 7. And we multiply the bottoms. 4 times 11. 3 times 7 is 21. 4 times 11 is 44. That's all we can do. So that's how we multiply fractions by a whole number and by another fraction. What about division by a fraction? So this maybe gets a little bit trickier. So say we want to do 5 divided by 2/3. So a whole number divided by a fraction. So to divide by a fraction, first of all, you flip him over. So we're going to get something to do with 5 and 3/2, like that. So you flip the fraction over and then you multiply by him. So we get 5 times 3/2. So again, we're now multiplying by a fraction. 5 times 3 on top and 2 on the bottom. So 5 times 3 is 15. We've got 15 halves. Okay, so 5 divided by 2/3 is 15 halves, which again is an improper fraction. We'll get onto those in a moment. What about dividing a fraction by a fraction? So let's say we want to do one that's come up actually on a paper recently. We wanted to do 7/4 divided by 35/6. Lovely. So for this, we flip 35/6 over first of all, and then we multiply it. So we get 7/4 times 6/35. Now, we then multiply these two fractions together. It was on a non-calculator paper. So to do this, I'm going to show you the product prime factor method again, because we get quite horrible numbers without a calculator. So up on top, we get 7 times 6. On the bottom, we get 4 times 35. So let's write that fully in terms of products of primes. So 7 already is a prime number. And then we got 7 times 6. 6 is 2 times 3. So we can go for 7 times 2 times 3 up on top. On the bottom, 4 is 2 times 2. Then we got times 35. 35 is 5 times 7. So a reason for doing it with this method is that instead of having to do a multiplication like 4 times 35, which is 140, we're instead breaking it down to its building blocks that we can then cancel down with the building blocks up on top. So let's have a look at what we can cancel down. We've got a common factor of 7 by 7. Then we've got one common factor of 2 by 2. So we're left with 3 over 2 times 5, which leaves us with 3 tenths in its simplest form. jump again. So far guys, if you want more examples of anything that we've been through, there are more videos. It's why my voice isn't quite working. I spent the last year making almost 300 videos to help you guys. So, hope you find them useful. Okay, so what have we done now? We've done division and multiplication by fractions. Next, we'll have a look at improper fractions and mixed numbers. Okay guys, and I think on that we are done for this video. So, it's very important to realise that's not all that we need to know, but pretty much all that we need to know for the non-calculator paper is an application of these skills. So, anything that you do uses addition, subtraction, multiplication, division. It's just different applications. So, if you're rusty or not sure with any of these skills, I do have videos on absolutely everything that we've done. So scope them up. As I said at the start, all of the non-calculator papers will be linked down below the video in the description, so I would highly recommend going through those too. Hope you found this useful. Don't forget to get subscribed, share with your friends. Most importantly, good luck.